about Fibonacci, you might not have much to do today. Okay. Make me happy. Please tell me someone has the answer to number 5.
Yeah, that's what I got. Yeah, that's what I got.
No, that's correct. You can have a point. The answer to number 6.
Me.
I am going to give it to 2 and 4 because one already got a point, and we expect more from Lauren than that. My gosh, Lauren. So 5 and 6 are good. Oh, by the way, we're doing these compass reviews. I know y'all have heard me say it, but they haven't heard me say it, so maybe they need to hear it. They're supposed to help you get ready if you have to take like a placement test for whatever college you're going to, in case you didn't score high enough on ACT. Okay, so 7, answer number 7 is
D. We playing D. D.
7 is D. I will give it to you, yes. And then number 8 to me is the hardest one of the day. And it is E. Now, the reason number 8 is the hardest is because it actually requires you to think in your own brain for that. There are 52 weeks in a year. There are 4 seasons. And there are 31 days in January. So you've got to add 52, 4, and 31 together. How do you find the average?
You add them together and divide by how many?
Perfect. So we got to divide by 3. And that's how we ended up with 29. Perfect. Okay, I want to do 9 and 10 tomorrow. I want to do 11 and 12 on Friday. If you had these done in advance and could shout out the answers the way group 1 is and steal all the points, then you can get you some points for being alive. Okay, you totally do. You're just overthinking your life. Okay, let's move on to what you did last week and Monday. So, Kenny, I know you got one. If you want to finish it, you can. And I'll go ahead and give you a grade. I don't know how bad you had your grade script in the last class. If you're needing some good grades, then do it. If not, then we'll just start off with the next thing. Okay, so you did your Fibonacci sequence and your stack with power worksheets. How come my stack feels like I got like 15 papers and I need like 20? So some people's are missing. Not my new, you just walked through the door. Some people's are missing. Make sure you turn it in.
No, somebody handed them back. That's
Oh, okay, yes, so you could fix it if you weren't done. Make sure you turn it back in because I'm for real looking at it. We're going to talk for a few minutes about Fibonacci and how this came up and why it's happening. But before we do that, let's talk about what else is going on this week. So I know you got messed up with 5.2. That's fine. We're going to fix that today. It might bleed into tomorrow. So here's the plan. I'm probably going to ramble, and you're going to help me ramble. And we'll go over the answers to 5.1. I'll give you hints to fix 5.2 and let you fix 5.2 tomorrow. Any problems you get done on 5.3 tomorrow will be bonus. So if Sarah finishes all of 5.2, she's getting all her points for the day, but if she does 7 problems from 5.3, she's going to get 7 bonus points. Okay, so 5.2 and 5.3, we're cutting it off tomorrow. On Friday, we're doing a quiz with our groups. It is a group quiz. We'll talk about that more in just a second. We don't have many sections left in Chapter 5. It's a fast one. Our test on Chapter 5 is one day next week. It is not a group test. Not a group test. You will get to use your Fibonacci sequence and practice our worksheet, any other notes you have, and of course your book, which is why we're going to go over the answers for 5.1 and after you finish 5.2, 5.2. That way Lana knows she has all the right answers, so if I ask a similar test question, she can figure it out. Are there any questions about that? Okay, so I was going to show you, I don't know if I can sit up here anymore. Feeling super pregnant today. Like exceptionally pregnant. Okay, I was going to show you about Fibonacci. So there was this mathematician. Oh, mathematicians are so weird. They just sit around with all their free time doing stuff. Who would come up with this? Like, get a hobby. I guess this was his hobby. That's ugly of me. So, where are you, dude? Who was Fibonacci? Okay, so Fibonacci is known as the greatest mathematician of the Middle Ages, and there is his portrait. Isn't he lovely? So he's credited with some things. You're like, okay, why is he the greatest mathematician? Here's what he's credited with. So he introduced the decimal system to Europe. The decimal system to Europe, Lord Jesus. He's credited with Roman numerals. No, he did not make them. Clearly the Romans made them. That's why they're called Roman numerals. But he helped people in Europe do math using Roman numerals, so he got credit for that. He also helped people with decimals, because apparently that was a problem for him. He invented this like algorithm, like the process we follow. He invented that. What I most love him for, though, is Fibonacci numbers, which is the pattern we were dealing with on our Fibonacci worksheet. The 1, 1, 2, 3, 5, 8. You always add the 2 previous, and if only you had guessed 5. Anyway, so did he invent this? No. People don't have to invent stuff in math. You just have to find it and be the first one to name it, and you get credit for it. So that's what he did. He's the first one to notice this pattern, give it a name, and of course he named it after himself. So if we look at Fibonacci numbers in nature, I've got a couple things to show you. So for instance, if you look at flowers and you count the number of petals, the number of petals is always going to be a Fibonacci number. So like the second picture of flowers, they have 3 petals. Or that sunflower has 13 petals. So if you go to your house today and you pick a flower and you count the number of petals, it's going to be a Fibonacci number. So one of the numbers we came up with that sequence. So 1, 1, 2, 3, 5, 8, 13, and it keeps going after that. Notice I didn't say number 4. And that's why 4-leaf clovers are so rare, because it's not a Fibonacci number, so it doesn't happen often in nature. Fibonacci numbers happen so often in nature that if you find a number that's not Fibonacci, like a 4-leaf clover, you've done something well. Okay, and then Fibonacci numbers even happen with your body. You have 2 hands, that's Fibonacci number. You have 5 fingers, that's Fibonacci number. I don't know how you think of the parts, but 2 or 3 parts separated by 1 or 2 knuckles. And then, of course, you can always find Fibonacci numbers in your food. If you were to go home and cut up a pepper, for instance, the number of sections you see in a pepper would be a Fibonacci numbers. And if Grant took the time to count the number of seeds inside his pepper, that would be a Fibonacci number. Like, whoa deep. Why does these numbers keep happening in nature? I don't know. I assume that was God, but I did not realize he loved math that much. I don't know. Of course I thought he loved math that much. What am I saying? Oh my gosh. So I was going to show you that not only do Fibonacci numbers happen in nature a lot, but so does the darn spiral. So the fractal spiral happens. Come on, Prezi. Oh, I didn't make this. I stole someone else's. But, you've seen pictures of the galaxy. They even kind of see the spiral going on in the seeds inside the sunflower. And they make the spiral using Fibonacci numbers. And that's what you were supposed to do on that very last page of your worksheet, but I digress. Even if you cut open, well, you don't have to cut this open. This certain kind of broccoli has the spiral on it. A pineapple, if you slice it a certain way, you can see the spiral inside it. Artichokes have the Fibonacci spiral. Cauliflower. And I know I have, when I've cut open red cabbage, noticed the spiral before. So creepy, the spiral happens everywhere. Then they get real deep. We're going to skip that. We're not that deep. We are deep enough to see, they're calling it folds, and they call it fractal dimensions. But there are tiny little fractal spirals all in our brain. And then, of course, we see it in nature. Or, like, this guy saw it in his school, so he saw it in the air vent. Good for him. You would have thought, like, in that, like, a seashell, of course. And then leaves, maybe even. Or a tree. By the way the branches are going, it makes a fractal spiral. You can see fractal spirals from space. There are fractal spirals in the ocean. And, of course, my obvious example for fractal spirals would be a hurricane. Hurricane with the eye looks exactly like a fractal spiral. Okay, you're like, Miss Compton, why are you going over all this? And I swear there is logic and reason. 1, I think it's super interesting. And 2, oh, by the way, if you messed up your fractal spiral, there is a particular way you have to draw it. 2, you actually have something you can do to get you some bonus points today. So you picked up a sheet on your way in. Grant, where's yours? No. Okay, you picked up a sheet on your way in. At the bottom of the sheet, it says Fibonacci Project. Okay, I know it says 3 examples, but you can do more than 3. I'm not setting limits. If you find 3 examples in nature, write a paragraph, and then draw me a picture or give me some sort of graphic to prove it, I'll give you your points. And I'm not excluding any of the ones I just went over. So if Sarah likes my hurricane, she can steal my exact image of a hurricane. She's just got to write a paragraph about it. You're not in elementary school, I need at least 3 sentences. Sarah can do as many as she wants. She's going to get 5 points per example she writes about. So if she writes about a hurricane, a pepper, a lemon, and her hand, she's getting 5 points per. And so you can see why she would need this, especially if her 5.1 and 5.2 activity she really didn't do. Someone else in her group did it. She didn't really understand. She would like to get all the bonus points she could before we take the Chapter 5 test on our own because it is a solo test. Okay, so we're going to say the Fibonacci project's due the day of the test, which is Monday next week. Are there any questions about that? Yes, dear? No, you do not have to be free. I was just setting a limit.
So we can get up to
I'm not setting a limit. I'm not setting a limit.
Oh, I've got another question. Can we do a PowerPoint instead of like...
Gosh, yes. Please, something that I look through at my email? Oh, yeah. That would be awesome. Okay, so one day next week, Fibonacci project due whenever we take the Chapter 5 test. Nope. Nope. You could draw me a picture of a flower, and then explain in 3 sentences why this flower shows an example of Fibonacci sequence. Don't care. Don't care. Okay, on Friday, so we're taking a for real test next week. That's all by ourselves. My God, Discrete, somehow it'll grade a merit. On Friday, we're actually doing a group quiz, and it's similar to this problem that we're about to talk about. So that's why I went ahead and gave it to you if you wanted to read it, but I'm going to show you a YouTube video explaining it. Now, before I show you this, if you think this is the exact quiz question, you're wrong. But it is similar, so if you understand what goes on in this video, you will be great on Friday. Okay, dude. Okay, this video goes pretty fast. I'm going to post it on Google Classroom as well, in case you need to see it. I need to give the 3 of you my access code, so you know. Okay, I'll work on that while this plays. It goes pretty fast, so if you want to rewatch it at home, you can.
Hey Math fans, Jason Marshall here with a special look at the solution to Fibonacci's rabbit problem from Math Food episode 16. Here's Fibonacci's question. If 2 newborn rabbits are placed in a pen, how many rabbits will the pen contain after 1 year? To answer his question, Fibonacci wanted us to assume that rabbits always produce 1 male and 1 female offspring, that they can reproduce once per month, that they can start to reproduce when they are 1 month old, and that rabbits never die. So that's the question. What's the solution? Well, let's think in terms of how many pairs...
Okay, is that realistic? No. Rabbits do die. Do they always have a male and a female? No. Do they always reproduce that often? No. So a lot of this is fictitious. But let's roll with it.
Of rabbits are in the pen at the beginning of each month, starting with the 1 newborn pair in the pen at the beginning of the first month. These newborns are too young to reproduce, so we begin the second month with 1 pair as well. It's the same pair, but they're now adults that are mature enough to mate. As a result, 1 new pair of rabbits is born at the end of the second month. So at the beginning of the third month, we have a total of 2 pairs. The original pair again mates at the beginning of that month, but the newborn pair does not. The original pair produces another pair of offspring. So at the beginning of the 4th month, we have a total of 3 pairs of rabbits. The original pair, their newest offspring, and their first pair of offspring, which are now adults. 2 pairs can now mate, and they each produce yet another new pair, giving a total of 5 pairs at the beginning of the 5th month. Now, 3 pairs can mate, So after the 3 new pairs of offspring are born, our total moves to 8 pairs. At this point, the sequence is 1, 1, 2, 3, 5, 8. What's the pattern? The trick is that each number in the Fibonacci sequence is obtained by adding together the previous 2. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8. You can keep going and going on like this to find subsequent numbers, and after 12 months, you'll get 144 pairs of rabbits. In other words, the 12th Fibonacci number is 144. But is that how many pairs the rabbit penny would actually contain after 1 year? No. That's the number of pairs in the pen at the beginning of the 12th month, not the end. So we actually need the number of pairs at the beginning of the 13th month, which is 233 pairs, or 466 rabbits. But how does that compare to the exponential growth of the model where rabbit populations grow like a geometric sequence? The difference is huge. If the rabbit population grew like a geometric sequence and doubled every month, at the end of the year, there'd be 8,192 rabbits. And that's the story of Fibonacci and his rabbits. Until next time, this is Jason Marshall with this week's Math Food Video Extra.
Okay, so what I want to point out
with 1 pair as well. And their first now
is that
16 pair produces another pair of 5 pairs.
There you go. Okay, what I want to point out is just thinking through how I would do a problem similar to this. Notice how their baby rabbits are a different size than their giant rabbits. So some way to note the different sizes between 2 things. Again, you're not going to have rabbits, but something like that so I can note who is able to reproduce and who is not. And then notice the chart. Now, if you think I'm going to do the exact Fibonacci sequence of 1, 1, 2, 3, 5, 8, 13 on your quiz on Friday, you are wrong. But it will be some sort of sequence where you add the 2 previous and get the next term. So as long as you can figure out the start, life should be good. It's just if you mess up the start, you've messed up everything else, and suddenly your whole quiz is wrong. Okay, are there any questions about this? Okay, well then if you've got your textbook, y'all don't, if you've got a textbook, go to 5.1. I want to go over the exact answers so we're all on the same page. As for my people who don't have a textbook, I need to rectify that immediately. Let me see. Drive. Did I give you, Nick, did I give you a copy of 5.1? No? But I gave you 5.2. I need to give this to her. Print. Do I have a 5.1? Let me see. I do. Why? Can you look on you for now? Penny, can you see one of their books for now? Grant, let her look at your book for now. I swear I will give you your own copy of Stuff Series. I'm just on it. Okay, I want to go over the answers to 5.1. Theoretically, if my hover cam is going to cooperate now and it's not. Which is my own fault because I unplugged it. Okay, if you can tell me the answer to each problem, if you're correct, your group will get a point. If we need to go over any of them, we sure can. What is the answer to number 1 on 5.1? Go ahead.
Is it 5.1?
Yes.
I put 1. There would only be 1 root to choose from.
That is correct. Why? What would that one root option be? All what kind of things? Huh? All the things. Okay, so we're going to get a table at her point. Number 1, is there 0 patterns? Oh, sorry, 1 pattern. This company's getting ahead of herself. 1 pattern, and it would be all triangles. 3, 4, 5, 6, 7 triangles. Woo. Okay, I don't know about you, but I'm tired of drawing the triangle. So what Claire does is she draws it differently. And what the textbook does is it starts doing T for trapezoid, T for triangle and T for trapezoid, or maybe to use 2 letters so you don't have to keep listing out and drawing stuff. Because my triangles and trapezoids are getting ugly and uglier. Okay, what is the answer to number 2 on 5.1?
0.
It is 0. I heard it from 1 and 5. Yeah, I knew I heard it from places. Okay, so we've got to have, we're in this situation when there are 7 houses. So we could have a trapezoid, a trapezoid, a trapezoid, but that's only covering 6 houses. There would be 1 house with no roof. You have to have at least 1 triangle. There are 0 options with no triangles. Okay, and then number 3.
I said 7. There are 7 roofs, and it takes up 1.
There are only 4 options.
Okay, so we're going to give 1 and 2 the point. Because it is 4 patterns, or 4 options. But Tangela's right too. We have the option of 7, 3, 5, or 1. That's how they're getting it. So I could have all triangles. 3, 4, 5, 6, 7. Let me make that go away. Okay, I could have all triangles. I could have 3 triangles. 1, 2, 3. And then 2 trapezoids. 4, 5, 6, 7. Or I could have 5 triangles. 1, 2, 3, 4, 5 triangles and 1 trapezoid. Or I could have just 1 triangle and 1, 2, 3 trapezoids. That is correct. There are 4 options. Okay, I don't know what number that was. Tell me the next thing.
4.
Oh, was that you, Sarah? Okay, you're almost there. Okay, so Sarah said 3, 2, 1. She's missing something.
Yeah, I said 3 at the most. 1 takes up 2 roof spaces.
Would it be 0?
Okay, so I'm going to give 1, 2, and 5 a point. Yes. Now, yes, there are 4 of those options total, because 3, 2, 1, 0, that's 4 different options. And Tangela was explaining it well. I could have 3 trapezoids, 2, 3 trapezoids, 1 triangle. I could have 2 trapezoids, and 1, 2, 3, 4, 5, 6, 7, 3 triangles. I could have 1 trapezoid, 1, 2, 3, 4, 5, 6, 7. That option. Or I could have no trapezoids, which means I'm all triangles. 2, 3, 4, 5, 6, 7.
So is
And
it,
hopefully by now you're like, Miss Compton, why are you making the same pictures over and over? Yes, dear.
so is the answer 4 options?
Yeah. But if you explain this, then you're fine. You're still going to get all your points in life. Okay, number 5.
6. And I did a triangle, 2 squares, and 4 triangles.
I believe.
Am I right? Yeah.
No, I'm pretty sure she's right. It's 6. Okay, so it's 6. So it says specifically that you have 1 trapezoid, or does it say specifically you have 5 triangles?
1 trapezoid.
Okay, so I can put the 1 trapezoid in front, and then triangles in the rear. 1, 2, 3, 4, 5, 6, 7. I could put that 1 trapezoid in the second slot, so a triangle, then the trap, and then keep going. Maybe I do triangle, triangle, then the trap, and keep going. And eventually, for the 6th option, I've done all my triangles in front, 2, 3, 4, 5, and then my trapezoid on the end. Okay, while that was all fun and games, if we were trying to skip ahead in life, what problem ties to number 5? You get the point, ma'am. 5 and 8 ask the same question. Now, they don't literally ask the same question. Number 5 says, I have 1 trapezoid. But number 8 says, hey, what if I had 5 triangles? Well, if you have 5 triangles, you have to have 1 trapezoid. So they're really the same question.
number 6 and 7 the same.
Yes, and you can point for that, ma'am. 6 and 7 are going to go together because 6 asks for triangle trapezoids. Is it the 4 one?
Yeah. No, it's there are 3 striped trapezoids.
So 3 trapezoids. So I could do the 3 and then the 1 triangle, or I could put the triangle in the front. Trap, trap, trap. My traps are getting uglier and uglier. Or I could do trap, triangle, trap, trap. Or I could do trap, trap, triangle, trap. So seriously, it's just us moving around this triangle. He has a beginning, next slot, third slot, last slot. He has 4 options. Number 6 asks about the 3 traps. Number 7 asks about the 1 triangle. But if you have 1 triangle, you have to have 3 traps. If you have 3 traps, you have to have 1 triangle. They go hand in hand. And so the answer to this one is 4. Okay, and before we go crazy and talk about 9, 10, 11, 12, all that jazz, well, obviously you've already answered number 9. Number 9 is implying 5 and 8 go together, and 6 and 7 go together. Before we go any further with any of that, there is something kind of obvious I need to point out. This is going to break your heart a little bit. Just a little bit. What's 6 divided by 2?
3.
What's 4 divided by 2?
2.
Okay, and then we already had this guy with the 1. So I see the 1, the 2, the 3. I don't know where the other one came from. I'll have to think about it in a few minutes. So if you were stuck on number 10, I already know the answer because I realized this is a multiple of what sequence?
I know it. Brittany!
What is it a multiple of?
Okay, I said if there are 5 triangles, there must be 3 trapezoids.
Yes, she's genius, but I'm trying to help a girl out.
Oh.
And I'm telling you this is the Fibonacci sequence. Now it's a multiple thereof because I get 6 divided by 2 is 3, and 3 was a Fibonacci number, not 6. 4 divided by 2 is 2. So I know the next number I'm probably going to need is 5. And 5 times 2 is 10. So the next missing number is probably going to be a 10. Seriously, I don't even bother to draw pictures at this point. Bless you. Bless you. I start understanding, like, yeah, let's go. If you didn't realize that, that's fine. On 10 and 11, I had something along the lines of 0 trap. Went with 7 triangles. 1 trap. Had to go with 5 triangles. 2 traps. That'd be taking up 4 houses, so we've got 3 triangles. 3 traps. And I have to have 1 triangle. That's what I did for 10 and 11. But to answer number 12, I had to do a little bit better job. I needed to get a bigger board. For number 12, and yeah, I stink. I seriously just drew an arrow in 11. I was like, and see my answer to number 2. On 12, they asked how many total options are there?
There's 21.
There are 21 total. So with the 0 and the 7, so we did 0 trap, 1 triangle, and there was only 7 triangles. And there was only 1 pattern with that. We did 1 trap and 2 and 5 triangles. And the 1 trap with 5 triangles, that was this picture. And there were 6 options for that. 2 traps and 2, 4, 3 triangles. Well, 2 traps, 3 triangles we had here. There were 4 options of that. That's not right. I'm on the next one. I need to get my left here. 3 traps. I'm thinking of the last one. 3 traps and 1 triangle. And there are 4 of those. The only one we had to figure out was this one. So either you drew you a picture to figure that one out, because that's the only one we haven't already drawn out. That's the only scenario that I don't feel like we've evaluated. So you could either draw out all your options, which is what Claire did, Or again, maybe you're smart enough to realize these are Fibonacci numbers. There's a pattern going on. I know it's 1, 1, 2, 3, 5. I know 4 divided by 2 is 2. 6 divided by 2 is 3. If this is the 5 multiple, 5 times 2 is 10. So I knew this one was 10 because I know my Fibonacci numbers. So yeah, the answer is 21, but I didn't have to draw any pictures because I just know my Fibonacci numbers. Okay, and then after that, we're calling it a day on 5 point. I know there were more questions than that, but if you can do up to number 12, then you can do 5.1. Okay. Let's look at your 5.2. Did he tell you there was a formula?
Yeah. Well, there was a formula that we understood at first, and then he tried to do another formula, and it just wasn't right.
Okay.
Not right.
Okay, well, I am going to erase. And let's talk about 5.2, which...
No, I don't know about these.
I know.
I mean, I do, but I don't.
Let's talk about it, which I'm going to hand you now, ma'am. Okay, so, you're welcome. 5.2 is asking about this girl and her piggy bank ever increasing every day. Must be nice. I wish mine was. So you understood it was increasing. So a long time ago we joked, we went through permutations and we said 4 factorial was 4 times 3 times 2 times 1. And then Claire joked, why don't we do, if we're adding 4 question mark, so 4 plus 3 plus 2 plus 1. And that's really the world we're living in 5.2. It's always adding previous. But is there a button on the calculator that's really a question mark that lets you do that? No. So would it be so much nicer to know there's a formula we can use? Absolutely. So, n plus 1 divided by 2. So if we're on day 35, seriously plug in a 35 for n. If we're on day 200, seriously plug in a 200 for n. Okay, so number 1 says on day 35.
So number 1, 5.2.
Yes, he's asking that. Okay, read the question though. It doesn't say how much is in their piggy bank, does it? It says how much will her mom give her on day 35. She's got to give her 35 cents. How much will her mom hand her on day 200? $2. Okay, so no, we don't actually get to use this until we start asking specific questions about the girl's piggy bank. Or her savings, or whatever you call it. This formula helps you figure out the piggy bank, how much money her mom is handing her. That's kind of common sense as to what day it is. Okay, I'm going to let you have some more time on that. I just think you need someone to not use words at you and you can handle it. I've been wrong before there. Okay, I'm going to stop talking now. Work on your things. Ooh, I have an answer for you. Grant, put this back where it was.
We're going to have a group test or quiz.
Quiz is group, test is not.
So we're having a quiz as a group.
Yes,
And
on
then we're gonna
Friday.
have a test.
Next week. That's not group.
For that test.
Yes, you get to use your textbook, the book, your notes, anything you got, as long as it's not your people at your room. And obviously the internet. The internet is all answers.
Are you doing 10 bonus points for
Your 5 paragraphs.
so 20 of them?
Yeah.
Could I just not take the test?
Because you're going to take it, so I have a key. But yeah, you cannot grade it, yes.
Okay.
Yes.
Okay.
Yes.
I was,
But I appreciate you not saying that loudly.
yeah, I know. Well, because
I really appreciate that. Grant, make sure Brittany has all the answers for 5-1, and I just want to.
I got all the right answers. Oh.
Why are you being smart, Grant? Angela's trying to help. This is why they get mad at you.
I got all the answers too.
She does. She answered all the stuff out loud.
Yeah, and I got our group points.
She did, and you're trying to take them away by being sassy. She might. She might not.
I might not.
And always. Yes, dear. Yes. Yes, dear. I got your nose ring. Oh, that would be easy.